Hey, Mr. Long, this is for FRQ 2. So for part A, to get the free body diagram of all the forces acting on the block. There's the applied force. There's a force of kinetic friction acting against it because there's a coefficient of friction, meaning that there's friction along the surface of the block. There's a force F of G, applied force. This is F of K, and then there's an equal but opposite force, F of N, because in this case, the block is only moving in the horizontal direction. So these two are equal. For part B, to find F of K, we know that F of K, kinetic friction, is equal to the coefficient of friction times the natural force or normal force. But in this case, as I said earlier, the normal force is equal to the force of gravity, which is equal to mass times gravity, or weight, which is also given to us as 44.5 newtons. And the coefficient of kinetic friction is given to us, so we get 0.4 times 44.5 is equal to 8.9 newtons. Okay, so for part C, it's asking for dx over dt, which is equal to the derivative of the position function, which is equal to the velocity function, which is also equal to the integral of the acceleration function. So since we're given things in forces, such as the applied force, I'm going to try to find the integral of the acceleration function, since force is equal to mass times acceleration. So the net force in the x direction is equal to the applied force minus the force of kinetic friction, which is equal to mass times acceleration. To find mass, we're originally given weight, which is 44.5, and I'm going to divide that by 9.8 to get 4.54 kilograms, because as I said earlier, weight, or the force of gravity, is also equal to mass times gravity. So the applied force we're given as 8t squared minus 8.9, which we found in the last part, equal to 4.54 times 8x. So to isolate for 8x, I'm going to just divide everything by 4.54 and get 1.76 t squared minus 8.9. So this is my acceleration function. So to get the velocity function, which is also equal to the derivative of x of t, I'm going to take the integral of all of this, and I get the velocity function is equal to 0.587 t cubed minus 1.96 t plus 4, when we're adding 4 because the initial speed is given as 4 meters per second. So to find the instantaneous velocity when t is equal to 2, I'm just going to use the velocity function we found in the last problem and plug in t equal 2. So I'm just going to replace 2 for all the t's. and I get 0.587 times 2 cubed minus 1.96 times 2 plus 4. And when I do that, I get 4.778 meters per second. So to find the instantaneous velocity when the position is equal to 2, I have the velocity function already. So to find when the position function is equal to 2, I'm going to take the integral of this. So I get, when I take the integral of the velocity function, I get xt is equal to 0.47 t to the 4th minus 0.98 t squared plus 4t. And then to find when this is equal, what time is this equal to? 2. And I get t is equal to 0.578 seconds. And to find my instantaneous velocity at this time, because at this time the position is 2, I'm just going to plug this in for my velocity function. And when I solve for this, I get the instantaneous velocity is equal to 2.981 meters per second when the position is equal to 2. To find S average, we know that speed average is equal to distance over time, and using calculus, we know that distance is equal to the integral from time a to b, which for us is 0 to 8, the absolute value of v of t, which gets us the distance over our change in time minus 0, and we get 71.29 meters per second. So for part G, we're looking for the velocity time function in a graph. So we know that it's only going for 8 seconds. So for our x-axis, our velocity time graph, our x-axis will be our time, and our y-axis will be our velocity. And the x-axis will be our time. So we know it only goes for 8 seconds, which is the entire motion. And for these 8 seconds, the velocity for each is initial velocity is given as 4 meters per second. T time 1 is 2.62. Time 2 is 4.77. Time 3 is 13.96 meters per second. Time 4 is 33.72 meters per second. Time 5 is equal to 67.57 meters per second. Time 6 is equal to 118.032 meters per second. Time 7 seconds, these are all in seconds, 191.62 meters per second. And time 8 seconds is equal to 288.864 meters per second. And I got this by just plugging in time into my velocity function. So 8 seconds, our latest time is 288. So I'm going to scale this accordingly. And I get 60, 20, 40. Oh, no. This is 180. This is 240. And this is 300. So that times 0 is equal to 4. I'm going to say that's about here. Very low. Time 1 is equal to 2.62. About here. I'm trying to scale this as best as I can. Time 2 is equal to 4.7. At time 3 is equal to 13.96. Oh no. So my graph, starting at the initial velocity, should be 4. It's very low on the graph. And then 2. And then 4.77. And then, this should be about 13.96. At 4 is equal to 33.72. At 5 it's 67.57. At 6 it's 119. 7 is 280. Oh, at 7 is 191. And at 8 is 288. So these are my plotted points, which are a bit hard to see. I'm just going to connect them now. And this is my velocity of the block as a function of time graph.